You guys are ready? All right.
Yes, sir.
So
Yeah.
it's a very recent experiment, and the need came about in some family members that are Windows computers, but they wanted to back up their files, and the various criteria were, it should be encrypted. Therefore, the SSD is encrypted. And only the owner of the computer, or actually the physical SSD, has the decryption key. The key or the passphrase can just be memorized, written on paper, stored however you want. It can also be, but need not be stored on any electronic device. And finally, it is still Linux. It is encrypted using the Linux Unified Key Setup called LUKS, on which we have an ext4 Linux format. Second objective was to use free and open source software. Of course, I didn't want it reliant on any cloud-based storage. It should be used on a device that can be easily attached or detached, can be physically stored in a secure location of one's choosing. It should be small and reasonably portable, and with a capacity that fits one's budget. It can be hundreds of gigabytes or more than a terabyte, whatever your pocket can stomach. So there's only the initial cost and no subscription fee. If you want to read more about the LUKS, there is a Wikipedia link that I have put on the bottom of the page. Somebody asked a question in the forum as to why do I not choose to utilize the built-in encryption that may come with certain drives. My hesitation from using that is, one, I know LUKS very well. I've been using it for more than a decade. Second, it is open source. It is very well supported, very reliable. I don't know that I have the same confidence of something that's embedded in a hard drive where the source is not known. If, for some reason it goes bad, you're relying upon somebody else to give you that tech support to recover, etc., etc. My basic distrust of closed source is my reasoning. That being said, what was the need? It's basically family members who use Windows 10 or more to back up data to a device that they physically possess. What's the history and experience and track record? I've used, as I said, LUKS on Linux computers for more than a decade. It's proven itself as reliable day in and day out with multiple devices. In fact, the device that I am on right now runs LUKS. It's a Linux machine. What are the limitations? The backup is only as good as the storage location of the SSD, besides, of course, the SSD itself. So if the SSD gets corrupted by premature disconnection, the data could be lost. If the SSD fails, then the data could be unrecoverable. Or if the password is lost, so is the data. So those are the limitations. There were other options that I considered. Windows 10 or above offers Bitbucket, which, to my opinion, perhaps is incompatible with Linux. I kind of did a lot of searching, but nowhere could I get somebody's absolute assurance that, yep, it can be made to work with Linux. In the Windows home version, it's a watered down version. And finally, it's linked to a Microsoft account where the key is stored. Again, for me, a no-no. I just can't allow myself to say somebody else is also storing my key. Then I looked at third-party software, those that are free or paid for software. There was Veracrypt, there is TrueCrypt, there was Discryptor, AXCrypt, etc. Again, compatibility with Linux is either non-existent or questionable. And then I've answered that question again about what about built-in encryption in the SSD itself. You know, and basically Linux compatibility is not known. They usually say are supported by Windows and Macintosh, but rarely does anybody even mention Linux. So I'm not willing to spend the money to experiment or risk one's data. That being the background, let me talk about the hardware. Back again. All right, so you need two computers now. One computer that is running a fairly recent distribution of Linux. I use Debian, Ubuntu particularly. You will need this for formatting the USB SSD as with the LUKS encryption and then the ext4 partition that's created on inside the LUKS partition. And of course, now the computer that is running Windows 10 or 11, in which Windows subsystem for Linux, Bruce entered the waiting room. Well, Gary, I'll let you decide. Windows subsystem for Linux 2 is installed, which people kind of call it Whistle 2. And this is the computer that needs access to the USB SSD. It should have sufficient RAM. I would say probably 8 GB is the minimum. The reason being you need to run the Windows operating system, which is the host operating system, inside which Whistle
I run on a Windows 12.
Sorry, what was that comment?
Can I ask the question?
No, I think somebody's trolling. Yeah.
Yeah, it's Michael that's trolling. His name was Bruce earlier, and now it's Michael. The real Bruce is sharing his screen.
Wait, Mark, weren't you the one calling me the nigger in the chat? Like, I think you're the one you're the one that needs to be kicked. You're the one drawing on the screen. You're the one doing everything. I swear to God, it's not me. I swear to God, it's not me. I swear to God, it's not me. It's not me.
Just cut this person off, please.
Oh, it's not
Cody. Yeah, Cody.
So the reason I said 8 GB was because you'll need at least 4 GB for the host operating system. And because Whistle is going to run Ubuntu as the guest operating system, another 4 would be necessary. And I think certainly 250 GB of drive space.
Hey, Mr. Knickerbopper Bobbity Bebop.
Who was that? I announced Cody.
No, so we need to show participants list. You might have to make the session private somehow. Yeah, that one. It probably just left.
No, I removed him,
Oh, good, good.
but I removed him before and he got back in.
Yeah, they just have the link on the site, I'm guessing.
Well, but they should go into the, can you click on the participants? To make sure they're all gone. No, not the right arrow, the actual link.
Yeah. You recognize most of these people, or any of them?
Yeah, there's only one Bruce.
Recognize Victor. Michael Stott, Mark.
Should we do some sort of a sound off, I guess, for those of us who are brand new? I mean, my name is Jonathan, by the way. Sorry, I'm getting my other camera here. I thought my camera was there. There we go. I'm new. I just found you guys online, so I was the one who was asking the question about Bitwarden versus Bitbucket. This is a different thing. So, but yeah, I'm new.
Welcome, Jonathan.
Yeah.
Well, thank you. Thank you.
Welcome.
Thank you.
Welcome. Yep.
Okay.
I'm sitting here as co-host.
Let's try and continue. So I've got some images of the actual hardware. I won't go over the details, but since you'll have the presentation later on, you can look it up. If you want to prepare the USB SSD with LUKS and ext4 using a Linux computer, I only briefly describe it here. There is a very good IBM article listed in the last slide where I say reference for LUKS. It's very well written, and that shows the command line way to accomplish it. If you are interested in an easier way, you could utilize the Ubuntu disks. The Ubuntu disks utility and use the GUI or the graphical user interface to doing the same thing. It's fairly straightforward, and it takes not more than a few minutes, but you'll have to give it some time for formatting the ext4 partition. So that's part A, which you're going to do on a Linux computer. Part B is installing and configuring a Windows machine to use this USB SSD. Of course, you'll have to install Whistle2. You'll have to install Ubuntu as the guest operating system in Whistle2. And then you'll have to install necessary software, the scripts, the shortcuts and the icons, and all of that. I'll pause here for any questions. Okay. Section A on the Linux computer. So this is where, first of all, you need to ensure that you've installed crypt setup and the GNOME disk utility. If you install this GNOME disk utility, and generally they are installed by default, but if it isn't, you can use the sudo aptitude command or the sudo apt-get command. If you use the disk utility, if you've done everything correctly, you will see an image like I show on the right-hand side. Let's assume that it has the F drive as the sequential drive that was found in your machine. In my case, that was so. You will find that the 1 terabyte that I was using of the USB SSD right here, the 1 terabyte. By the way, can you see my mouse cursor also move on your screen?
Yes.
Good. That then gets partitioned, first of all, into a LUKS partition, which is almost 1 terabyte, but for the 34 megabytes in the front and the 30 megabytes in the tail end. That's the encrypted partition. Inside this LUKS partition, you would have created the standard ext4 partition. And if you want to generally, get to that, you can navigate it by going to the mate desktop, which is what I use. I don't use GNOME desktop. If you go to the menu, you can go to the all option and then search for disks or look for disks, and then choose encrypted LUKS. Once you go through that, you can then format it as ext4.
I'm sorry to interrupt. I spoke too soon. I thought the cursor on screen was your cursor, but it's actually my cursor.
Ah.
I don't see your cursor.
You don't see my cursor. Okay.
No, I can see your cursor as you're moving it. It's a red cursor.
It's a red cursor, correct.
Mm-hmm. Yeah, I can see it from my side.
Excellent, thank you. So
Projection monitor.
just be careful. You may have, definitely you will have more than one drive. Make sure you select the correct drive letter. Don't make a mistake. You could accidentally wipe out the operating system that you're working in. Having done that, this is just a minor suggestion. Create a file at the top level of the USB SSD within the encrypted partition when it is in an unlocked state by saying touch, which is create a file basically. The drive will show up. If you followed my instructions, it'll show up as /mnt/USB-SSD if that's what you chose to name it. And then the actual file I just created is, if you can see this, it is unlocked. This will be useful later, as you will see. You can then unmount and disconnect the USB SSD. You're done with the Linux computer. Part B, on the Windows machine, 10 or 11. There are nuances to both of them, and I will cover what works well and what is sort of more tedious. Windows 10 is a little less capable. It's not as clean an installation as you will find in Windows 11, and I'll talk about why. All right. So, how to install Whistle 2, Windows subsystem for Linux. It's as simple as you, in a Windows computer, you say, okay, I want to open up PowerShell, and I want to run this as administrator. Once you have a terminal, you just type in the command WSL -- install. There's a space between the two words. And then you reboot your Windows computer. In case you want to know how to do all of this, I've cited a location where you can go read about it, learn about it. It is a Microsoft website. Having installed Whistle 2, you can then, in that same terminal, say, okay, give me a list of all the operating systems that are available in the Microsoft Store. I chose to exclude several of the names, and I only limited myself to Ubuntu because that's what I'm interested in. And you can find everything from 18.04 all the way to 24.04. 2022 inclusive. I have installed 18 as well as all the way up to 24, and you can install more than one flavor in parallel. And one of them will be designated as the default. You can select which one you want to be the default if you choose to do so. But I would say keep it simple. Pick the latest one. They are all LTS, namely long-term support, which Ubuntu's policy is every 2 years they come out with an LTS version, which is supported for a full 5 years. That's great. I mean, I like the idea that by April or late April or May, I know that there is a new, fresh LTS version available every 2 years. The next command you would choose is whistle space -- install followed by Ubuntu -2404. It will say installing, and then there will be a progress bar that shows you the percentage of completion. When it is done, it will ask you to enter a Unix username. Choose your username, type in a password you want to use, retype the password, blah, blah, and very soon it'll say done, ready, available, and it will open the Ubuntu terminal automatically. Now Ubuntu is installed. On the right-hand side of the screen, I have some useful commands. If you want to know about whistle, you can say, okay, whistle dash dash help. It shows you the various options. When I spoke earlier about how to set the default version, should you have more than one version installed, there's the command whistle space dash dash set default space Ubuntu 24.04, or whichever one you want. Now you got whistle installed, you've got the host operating system installed. We're ready to do the actual work.
Can I ask a question?
Yes, you sure can, but you may not. No, that's what I tell my children. Go ahead.
Well, why would one, and again, I'm new here, so
No question is that. Please go ahead.
kid gloves here. Why would I want to install multiple versions of Ubuntu on this PC rather than say the latest and greatest and keep it moving from there? Because if I'm doing this, say for a family friend kind of thing, you know, having multiple distros on this machine may cause some confusion later on down the road.
No, absolutely, I agree with you. But as I said, everything is an experiment when I started out on this project.
Totally understand. Thank you.
It's mainly for people who are playing around with
developers like testing to see if their stuff works on different distros.
Correct.
Yeah.
Correct.
Understood. Thank you.
Yeah, I like to play around. I kind of try to push it to the limits and saying, okay, I do have multiple computers running multiple versions of Ubuntu. So it was just my curiosity to say, can I also do this in Windows? Just like in Ubuntu, I can install Windows 98, Windows 10, Windows 11 as multiple host operating systems in Ubuntu. I wanted to try the reverse and say, in Windows, can I install multiple Ubuntu versions?
There we go. There we go.
Good question. Thank you. But yes, normally, if you're trying to do this for somebody that is doing this for the first time, keep it simple. Go for the latest. You're probably better off. I've not seen something that doesn't quite work in 2404 that did work in 2202. Sorry, 2204. Okay. Let's test Ubuntu inside Windows 11. Now I'm switching gears and saying, I'm going to talk exclusively about Windows 11 for a reason. This is where it works better than Windows 10. So now you're sitting at a bash terminal. Ubuntu is open. This is an Ubuntu terminal. I would recommend that you go out and get something called X11 apps. So sudo apt-get or aptitude install X11-apps will install various apps, of which xeyes is the one I'm after. So the next command where you type xeyes followed by space ampersand, the and ampersand, if you're not familiar in the Unix world, is run that particular command or software and give me control of the terminal back again. That has been spawned off, and I want to type something further on the terminal. What that xeyes does is it opens up what you see on the right-hand side is a two sets of eyes, and as you move your mouse around, those eyes will kind of rotate around, showing that your X11 terminal that is being permitted by Windows 11 to allow the guest operating system's GUI application to actually work in
What do you think?
Windows. Don't.
Okay, Jonathan has his hand up.
Why is this important? It's important because, first of all, you want to ensure that a GUI application that's running in the guest operating system, namely Ubuntu, is permitted to utilize the screen that the host operating system has control over. Otherwise, you just cannot run any graphical applications that are in Ubuntu. This is one way of checking it. Another quick test is to say, in the bash terminal, is echoing the environmental value of the environmental variable $display. It should give you this value :0. If it is blank, which will be in the case of Windows 10, this XIs will not work. It just doesn't show anything. That's the problem. Because I tried to do this and I said, okay, in Windows 10 and Whistle, using the same Ubuntu 24.04, I checked on the display variable, it is blank. So I said, okay, I'll export the display variable as specifically within quotes :0. And it says, no, this is not acceptable. It's not a valid value or something like that. So, having experienced this, it seems that GUI output from Ubuntu to the host OS Windows 10 is not supported, or I have not yet found a solution. So we will need a workaround for Windows 10, and there's more on that later. The next piece of software that you need, this is on the host operating system. You need a software called USB-IPD-Win. This is open source, again, and once you install it, what it does is, I'll stop here. I'll talk about it in the next slide. The next thing you need in the Windows subsystem for Linux is Linux tools. And it is of the generic form Linux tools something something. There are some numbers -generic. And you need to choose the right version for the kernel that you are running. Another useful thing to add to it is HW data, as well as crypt setup. You might ask, how are all these things installed? I'll show you. Let's first talk about this USB-IPD-Win. You can go to some downloads folder, and you can use wget, which is a Linux command, and you would go and get from GitHub this particular MSI file, or you can download it using a browser, save it to your favorite folder in Microsoft Windows, and install this like any other Microsoft software. Now, there is an important caveat here that your Microsoft may say that you're not allowed to install stuff from a non-Microsoft store, and you got to enable it somehow. I don't exactly remember where I managed to do this, but in my prodding and poking somewhere, it said, okay, you know, you can, I stumbled upon a setting that says allow non-Microsoft store software, and, or if you do a Google search, I'm sure somewhere somebody would have talked about it. But that's specific to your installation of Windows, whether non-Microsoft store location software can be installed or not. But what does it do? It provides support for connecting the USB devices, which is not natively available in Whistle. So you are really telling the Windows 10 or 11 operating system, hey, when a USB device is connected, allow the guest operating system access to the USB device. That's what this thing does. they did not implement this in Windows. This is a serious shortcoming. If you look at it in the contrary, if you're running Linux Ubuntu and you say, hey, I want the Windows operating guest to have access to my USB drives, yes, you can allow it pretty freely. But that's Windows. Okay, now you have told Whistle that the guest operating system may use the USB device that you've connected to it. So you need to bind it to Whistle. So as the administrator in a PowerShell, you can use the command USB IPD space list, and it'll provide you with a list. In that list, you will definitely see something like this. The bus ID is 1-5. In your case, it'll be different. There will be a vendor ID, the standard USB 4 numbers and digits, the hex numbers, followed by the actual device ID or product ID. It'll give you a verbal description of what it is, and it'll just show you the state that it's not shared. Now that you know that the bus ID is 1-5, you're going to type the command USB IPD space bind space -- bus ID 1-5. This is where you're binding that USB device to the Whistle Ubuntu guest operating system. Now it's important, ensure that this Whistle2 command prompt is open in order to keep the Whistle2 lightweight virtual manager or video manager, virtual manager active. And once it is attached to Whistle2, the USB device can be used by any distribution, namely in this case Ubuntu, running as Whistle2. Note that as long as the USB device is attached to Whistle2, it cannot be used by Windows. You've given its control over to the host, from the host operating system to the guest. The guest has control over it, the host has lost control of it. But that does not mean you can't use it from the Windows side. Don't let my statement mislead you. Yes, you can, and I'll show you how. Okay. Then you need to attach this device using the bus ID. Then you no longer, in this one, you don't have to be administrator. If all of this seems rather complicated, involved, too much typing, bear with me. It can be simplified. And I have simplified it. Okay, now you're in Ubuntu. You want to know if you have access to that device. You just do a standard LS USB, which is list USB devices. It'll show it to you right there, bus ID, device ID, and then it'll show you some technology. In my case, it was a Samsung. You can also find out what kernel version you're running, which is uname space -a. It'll tell you, hey, you're running, it'll tell you which Linux you're running. It'll tell you that you're running Whistle2. Now you need to install this Linux tools. In my case, I installed 5.15.0-97- Incidentally, I also installed hardware data as another package. Remember, I told you earlier, you need to ensure that you pick the correct version for the kernel you are running. Whoops. And then you need to run the sudo update alternatives, blah, 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 followed by the Linux tool / particular version, etc., etc. And then reboot your Windows computer. Now, because you have to find out what kernel version and all you're running, that's a little bit difficult. Here's the script that I have included that will go find what kernel version you're running and appropriately tell you which one is available, and then you can install it. So I leave it up there. I won't go into all the details, but it does work. I've tested it. So mounting the SSD. I'll go through this briefly. You've got to mount the SSD in Windows. Allow Windows, tell Windows to allow the guest operating system to be permitted to use it. So to do that, you're going to type this command, wmic disk drive list brief. And on the Windows side, it will show you the drive that you had just attached. It's the Samsung SSD 870, etc., etc. Whereas drive 0, the physical drive 0, is whatever is your internal drive that has Windows in it. Then you're going to type the command whistle mount bare physical drive 1 so that it can be mounted. And it will come back and say operation completed successfully. Okay. Now in Linux, you can do a DF, namely disk-free space H as in human readable. And it should show you right there that, hey, it is able to see this C program files USB IPD -win whistle. This will probably say 100 gigabytes or 1 terabyte or whatever. And it has been mounted as /run/USB IPD-win. This is that, how would I call it, virtual drive that's been assigned to the USB drive that you physically connected. If additionally you say, okay, list blocks, then it should show you a drive letter inside which there's the first partition, and then it will show you how much space it has and how much is used and so on and so forth. Standard Linux stuff. Now comes the critical part. You're going to unlock that drive. So you would say sudo crypt setup LUKS open, and then followed by whatever is the drive letter, and then USB SSD encrypted. Now it'll ask you for that password that you had originally used when you had created that LUKS partition. Okay. Now your drive will be unlocked. If you now do an LS block, in addition to the SDF letter or F1, etc., you will see another one hanging off of it that says USB SSD encrypted, which you earlier did not see. It was invisible to you. Having unlocked it, you will now see the encrypted partition available to you. Similarly, if you now do a DF, H. Oh, I'm sorry, I skipped a few steps. You will have to make a directory /mnt USB SSD encrypt, and you're going to mount this device mapper USB SSD encrypted as mount USB SSD encrypt. And it'll say operation completed successfully. Now, if you do a DF /H, it will show you, hey, okay, there is a device mapper USB SSD encrypted. so much has been used, so much is free, it's only 1% used, and it's been mounted as MNT/USB SSD encrypt. If you do listing of the files, either on the Windows side or on the Linux side, you should be able to see the files that are there. Okay. You're done. It's working. But all of this seemed complicated to do. Once you've got it set up, it's a little bit painful in the beginning to set it up. But if you follow it carefully, as I have spelt it out, it should work. I've done it both on a Windows 11 computer as well as a 10. Probably this weekend, I'm going to be repeating it on another Windows 10 machine. Now for the window dressing, the GUI window dressing. This is what one would like. You would like something that's easy, clickable, and quick. And that's my objective for the family members. I've taken some screenshots. I'm not showing a live view here. So the screenshots, basically, if you have installed Ubuntu, you should see on your taskbar a logo that looks like this. But we'll go about trying to create these 4 icons. I put them in a certain sequence because the sequence is important. The first one, I called it attach the USB. This is a PowerShell script that runs behind it. This accomplishes the task of Windows saying, okay, I recognize the USB drive, the physical drive. I must allow it to be used by the host operating system. It will be running that USB IPD-win in the background. Once that is done, you are then going to tell the Ubuntu Linux, hey, mount that LUKS partition. And that is where it'll say, okay, give me the passphrase that you had utilized for encrypting it. Once you do that, it becomes available. You can do whatever you want with it. List files, copy files, move files, synchronize files, delete files, whatever. Once you're done with it, it's important that you unmount the LUKS drive. In other words, you're locking it up again. And then finally, you're going to tell Windows PowerShell to detach that USB device. So it's no longer as simple as plugging it in and Windows goes bing, or your Linux machine goes, you know, hey, here's the drive, it's connected. It's complicated by the fact that you have to tell the host operating system to permit the guest operating system to utilize it. Then you're telling the guest operating system to mount it, as well as provide the encryption passphrase or password. Then you're telling the guest operating system to lock it back up. And then you're telling the host operating system, I'm done, disconnect the physical drive. Does that make sense now? I'll pause. Any questions?
I did have a question from earlier. What you're using Windows 10 or 11? Is it Home, Pro, Education? You know?
Good question. The Windows 10 I experimented on was a Pro version.
Okay.
So also the Windows 11.
Okay, yeah, I have a feeling. I just wanted, there was a permissions issue that I think you had mentioned, and I know that sometimes with home users, there's extra permissions that trips people up sometimes. I just thought I'd mention that.
Thank you. If I had more machines to play with, I probably would. And these are the areas that I really don't know. I haven't experimented that extensively. So it's a good remark and a good question. Any other questions before I move on? Okay. So breaking this down further, I will define them a little bit more. So when you click on the first icon, what it does is it attaches the device in the Windows side. And here it's going to ask for elevated permission. It'll say, allow this to be run as administrator, yes or no, and you would be saying yes. And when you say yes, it'll say, okay, all right. I will allow this device to be used by the guest operating system. The next one, when you click on that, is going to actually mount that particular drive in your guest operating system in Ubuntu. But at this point in time, it will ask you for two things. One is the sudo or root password, because mounting and unmounting devices in Linux requires a root password. But in addition to that, of course, it needs also your decryption or unlock password for the LUKS side of things. Now you're ready to use the system. Whoops, I didn't need to do that. Sorry, folks. I hit the end key by mistake. This is where I should be. We were here. I had stopped here when I messed up. The next thing is you do what you need to. You do your stuff. It's connected, it's available, play with it, etc. You can also look for this drive from the Windows side. You would possibly see it in a Windows File Explorer as a drive B, perhaps. And you can still use it from there. Once you're done with it, you would unmount it. Typically, it would require the sudo password and nothing more, because at this step, you're locking it back up. You're unmounting the drive in Linux. You're locking the LUKS partition. And the last step would be you would detach it. And this again is in the Windows side now. As administrator, you're saying, okay, I'm done with that physical drive. No longer need to allow the host operating system to permit the guest. We're done. And you're closing things up. Okay. As I said, this is done in sequence. Notice that the attach and detach are in the Windows side of things. And I've typo error here. It should really be Windows 10 or 11. But the inner portion of it, I can't create icons. And that's because it didn't permit XIs to work. Remember that? Because I can't get GUI access or allow Windows 10 to give me use of the graphical terminal, I can't create the icons, the penguin type of icons. But there's a workaround. So going back, you are going to attach and detach on the Windows side as the administrator. And on the Linux side, you're going to mount and unmount. And in between all of that, you're going to utilize it. The sequence is important. But how do you do all this? Well, there are 4 scripts behind the curtains. So you've got the open and the close part of it. So the PowerShell, which is the blue icons, they are really PowerShell scripts. And the inner penguin icons are run by Bash shell scripts. The window desktop shortcuts are basically link files, and they're binary files, and unfortunately, you've got to create them by mouse clicks. And as I call it, the usual Microsoft window user contortions or interactions. You can look it up as to how to create, icons on your desktop or shortcuts on your desktop. There are plenty of articles on it. But once you have your basic shell scripts written and ready, the creation of the icons is fairly simple, I believe. So we'll talk about 2 PowerShell scripts and 2 Bash Linux Ubuntu scripts. So behind that first icon, that is the PowerShell, I've shown you exactly what is in this script, verbatim. So this is where I placed it. I put it in C:users, my username, my files and scripts, and I call it mount USB-SSD.ps1. You just paste all of this that you see over here as that script. For the mounting part of it, this is a bash script, and you basically copy and paste this into a shell type file, which if you look at it either from the Windows side, it's in my case in the U drive, because that's how I associated my Ubuntu files on the Windows side, or you can do it right on, you'll find it here in the Linux side. It's one and the same file visible from either place. So what it does basically is it is using Zenity. Zenity is a GUI interaction software that says, hey, give me the password. So you will be typing the sudo password here. And then again, you use Zenity to say, okay, give me the LUKS passphrase. So now that you have typed in both, it'll show a success message saying the mount is successful, and so on and so forth, etc. It will do its thing. Behind the scenes, basically, it uses the sudo password and says sudo crypt setup LUKS open /dev SSD, whatever that drive may be in your case, and then the name of that encrypted folder that you had created. The unmount is simpler. It again just says, okay, give me the sudo password and run a command like sudo unmount the mount USB SSD encrypt. Finally, the PowerShell script behind that last icon that says, okay, time to disconnect everything. And that main command is right here. Whistle space -- unmount the drive that it was found. Okay. And the drive was found using this particular script. You would have to change the script because I have a Samsung drive. You will have to change it correspondingly to whatever kind of SSD drive your SSD drive is named. Now, looking at the Windows side of things, I remember I said I couldn't create these icons and because it requires the GUI functionality. It's a disappointment and a limitation. So we will have to run the bash scripts in a terminal. So instead of having nice clickable icons, you would have to open a terminal and run it as a bash script. What was running behind the icon, you just have to type that shell script to make it do the same thing. that's pretty much the end of the story. There are details. I've given you details about what is LUKS. And there's a really good reference here on how does it work. You can read that. That's where I got a bulk of this text from. And if you needed to change the LUKS passphrase, you can. And it can be done easily in that disks utility that I earlier spoke of, which you can go through the menu and then say menu preferences and locate the program called disks, or you can run it in a terminal which invokes the same thing, gnome disks, and then you select the appropriate disk, you select the LUKS partition, you click on the gear icon, and you say change the passphrase, you type in the current and the new passphrases, as simple as that.
Omar, is there a limit or guidelines on how long or complex the passphrase needs to be?
I don't think I've looked into that. I don't know the answer. I've used fairly long passphrases, but I don't know the limits.
I would
Look
just
it up
suggest
or
that-
at the time.
yeah,
I'll
12, yeah, 12 gotta be at least the minimum.
I agree.
These 12 complex characters.
Now, a couple of options. When you are getting a prompt in the Windows side, when it prompts you for a passphrase, there are three choices that it offers. I recommend highly that you use the first one, forget password immediately, for the most secure. You can, however, select remember password until you log out, which seems to be the first, when you open it up, it always seems to select that. And I have to always say, no, I don't want that. I want you to use the first option. The reason I don't recommend the second one is because this password stays in RAM. And if you're, for whatever reason, somebody is able to worm themselves into your RAM, they could discover what your password or passphrase is. Lastly, I would say never select remember forever, because it is stored somewhere on your drive of the computer. And for example, for your information, it is stored in the user's home directory under the .gnome2 keyrings login.keyring file. If you want some references, I've cited them down below. Namely askubuntu.com. It comes from there. There's a little tip here. Should you have selected remember password until you log out accidentally and you say, oh no, do I really have to log out to make it forget it? No, you really don't. You could, in a terminal, just type the command there, gnome keyring daemon -r, namely reset that password phrase. It'll forget it. So you don't have to actually log out. Let's see. And this is what it will say when you type that.
Hey, Kumar, this is Mike. The known keyring file is encrypted. And so it would keep your password in that keyring encrypted while you're logged in. It's not stored in RAM, it's stored in the keyring.
Are you talking about option 2 or 3?
Any of those options, if it stores a password in the keyring, the
Yeah.
keyring file is encrypted.
Okay, I understand that. But if I remember correctly, when I read this article here, they did clearly state that if you say forget immediately, it is not stored anywhere.
Right, it's not in the keyring. You have to type it every time you want to use it. Yeah,
Yeah.
I would agree. Yep,
So therefore I choose it.
sure. It's
I
the
may,
same-
you may be right about the fact that it remembers it somewhere, but if I remember correctly, it did say it stays in RAM. I
that would
agree
surprise me,
with,
but maybe.
sorry, say that again, please.
That would surprise me if it's
I
in
see.
RAM.
Uh-huh.
But I mean, anything's possible.
Understand. I will go back and verify.
But just the RAM to reboot and then it's all said and done.
Yeah, yeah. I mean, it's essentially become the equivalent of a passphrase, right? The pass keys that everybody's using now. Those pass keys are, I mean, it's a little less secure than a pass key, but it's in that key ring. There's all kinds of stuff in that key ring. For authentication.
Yeah, true. Let's see there, and then I've cited several references that I relied on to gather all of this. And oh, by the way, I utilized ChatGPT quite a bit to help me out with much of this. Because so much of it was, not readily available in a nice place, or I would have had to look all over for trying to make this work. So, questions, comments, or rewards? My usual closing. Okay, I take it that